Welcome. In this session, we'll recall the forward computation and back propagation for our simple neural network. The forward computations are, we have an observation X and we have a label for that, and we need to do these forward computations. The first is that the layer 2 linear response is the augmented observation times the weight matrix for layer 2. The responses for layer 2 we'll vectorize this, and it'll be the response computed from the first linear response times the activation of the second linear response. The input to layer 3 is this output augmented by 1. The linear response of layer 3, which is our output, is this input times the layer 3 weight. The output of the neuron is the activation applied to that linear response. The residual error is the label minus the response, and the objective function is just the ordinary squared objective function. When we go to compute the scale factors, what we do is we begin at the end and we compute the scale factor from the objective. So let's recall that this is just minus the residual error. The descent vector for layer 3 is this. We take the layer 3 input and transpose it so it's a vector, and then multiply it by the derivative of the response and multiply it by that scale factor that's coming, in this case, from the objective function. If we used a different objective, this scale factor would of course be different. The direction of steepest descent is negate that steepest vector, and what we'll do is we'll say the overall descent vector will set to be this this term. So if we only had one neuron in the entire network, that would be the descent vector. However, we're going to augment that when we go backward to layer 2. So the scale factor for layer 2 is, this will be, now it's not the same as the steepest vector. The steepest vector involves the input and the scale factors involve the weights, but they're both scaled by the derivative of the response and what we got from the objective function. So for layer 2, we take that layer 3 scale factor and we then compute a scale matrix. So we're going to vectorize everything, and this will be the vector of the vectorized input times the Hadamard product of the derivative of the responses of the activations for layer 2 times that scale factor, and then we have to transpose it to get all the linear algebra to work correctly. The single vector that represents the steepest direction is just the vectorization of this matrix, and then the descent vector is, we negate that. So that is all really that we have to do. The descent vector we then set to be the descent vector from the previous term, and we augment it. So you can see that this is a recursion, and if we had more and more layers, we would just keep tacking on to the end of it the descent vector for that new layer.